All right, listeners, ready for another deep dive? Today we're looking at this paper that's really making some noise in the large language model world. It's called the Autonomy of Experts models. And it gets into some really cool stuff about how these models can learn more efficiently.
Yeah.
So before we get into the paper itself, I think it would be helpful to give our listeners some background on how these large language models are actually built.
Yeah.
Because it's not just one giant brain doing everything right.
No, not at all. I mean, you're right. These models are getting amazingly good at so many things. Like you said, writing code, translating languages.
Composing music.
Yeah, even composing music. It's incredible.
But the problem is they need a ton of computing power, and training them can take...
It takes forever.
Forever. And that's where this idea of
Right.
mixture of experts comes in, or MOEs, as the cool kids call them.
MOEs, exactly.
Basically, the idea is to break down a large model into smaller, more specialized...
specialized experts.
Experts. So each expert handles a specific type of input.
Right.
And you only activate the ones that are relevant for whatever you're trying to do at that moment.
It's like having a team of specialists instead of one generalist.
Yeah.
Who's kind of okay at everything, but not great at anything.
Exactly. So it's like you have your, your language expert, your math expert, your coding expert.
Yeah, and they only get called in when their expertise is needed.
Exactly.
Which seems a ton of compute power.
Yeah. So it's a much more efficient way to build these large models. But
there's a catch.
There's always a catch.
Always a catch.
So what's the catch with...
So with most MOEs, you have this separate component called a router.
Okay.
And this router is responsible for deciding which expert gets activated for a given input.
Got it. So it's kind of like the
manager
who's assigning tasks.
Exactly. Or like a triage nurse directing patients to the right doctor.
Oh, I like that analogy.
Yeah.
So the router's like, okay, this input looks like it needs the math expert.
Exactly.
Let me send it over there.
Excellent.
Okay, that makes sense. But
the problem is...
What's the problem? What's the catch with the router?
Well, the router doesn't really know the expert's true strengths and weaknesses.
Oh, okay.
It's making decisions based on limited information, which, as you can imagine, can lead to some inefficiencies.
So it's like sending someone with a broken bone to a cardiologist.
Yeah, exactly.
Not ideal.
Not ideal, no.
And that's where this paper Autonomy of Experts models comes in.
That's right.
They're basically saying, what if?
What if, instead of relying on this separate router, we let the experts themselves decide which inputs they're best suited to handle?
Oh, so instead of having the manager assign the tasks, it's like...
Experts get to pick their specialty.
Yeah, they're like, I'm really good at this.
Yes, this is what I'm good at.
Give it to me.
Exactly.
I like that.
So the core idea here is that the experts have an inherent awareness of their own capabilities.
Interesting.
And this is reflected in their internal activation levels.
Okay, so walk me through that.
So when an expert processes an input, it generates this internal signal that indicates how excited it is about that input.
So the more activated an expert is, the more confident it is in its ability to handle that task.
Exactly.
Okay, that's cool.
And the researchers proposed this mechanism called Autonomy of Experts, or AOE.
AOE.
AOE, yeah.
Okay.
And this leverages that self-awareness to improve the efficiency and effectiveness of MOEs.
All right, so how does AOE actually work?
It's pretty elegant, actually. So first, all the experts get to process a tiny, compressed version of the input.
So like a little sneak peek.
Yeah, a sneak peek. Think of it like reading the abstract of a research paper before you decide to read the whole thing.
Got it.
Yeah, you get a sense of what it's about.
Yeah, and if it's interesting, you dive in.
Exactly.
If not, you're like, next.
Exactly.
Okay, so they get a little preview. What happens next?
So based on how activated each expert is by this preview, they're ranked.
Okay.
And the most activated experts, the ones that are like, I got this.
This is my jam.
This is my jam. They're selected to process the full input.
So it's like a competition amongst the experts.
It is a competition, yeah.
I'm the best. Pick me. Pick me.
Pick me. Exactly. And here's the key to the efficiency.
Okay.
Only those top-ranked experts actually do the full computationally expensive processing.
Oh, so it's like you're only calling in the A-team.
The A-team, exactly.
For the really tough missions.
Yeah. Everyone else can just relax and conserve energy.
We'll call you when we need you.
Exactly.
Okay, that's clever.
A very clever approach.
So it's efficient.
Yeah.
But does it actually work? Like, did they test this out?
They did, yeah. And the results are pretty remarkable.
Really? So tell me about the results.
So they found in a series of experiments that AOE consistently outperformed traditional MOEs across various tasks.
Wow. So it's not just about efficiency.
No?
It's actually better.
It leads to better performance, yeah.
That's really cool.
And they even found that AOE models learned faster
Oh,
and achieved higher accuracy than traditional MOEs, even when they scaled it up to a large language model with billions of parameters.
so letting the experts choose their battles
Right.
actually leads to better overall results.
That's what the research suggests, yeah.
More efficient, better performance, potentially faster learning.
Potentially faster learning, yep.
That's really impressive.
It is very impressive.
It's amazing what they're doing with these models these days.
It is. It really makes you wonder about the broader implications of this idea, you know?
Hold on, before we go there,
Okay.
I just want to make sure I have this all straight.
Sure.
So we've got this new approach called AOE, where experts within a large language model get to kind of self-select
Self-select, yeah.
the tasks that they're best suited for.
Mm-hmm.
This leads to better performance, more efficient learning,
Yes.
and experts that are more specialized in their respective domains.
That's a great summary.
Okay, good. I'm glad I'm following along.
Yeah.
So now I'm curious about those broader implications that you mentioned.
Right.
What happens when we take this idea of self-selection
Yeah.
and apply it beyond just the world of machine learning?
That's where things get really interesting.
Oh, don't leave me hanging.
All right.
Let's explore that in part 2 of our deep dive.
Okay, sounds good. Yeah, so, picking up where we left off, this idea of self-selection beyond machine learning is pretty interesting to think about.
Yeah, where do we even begin with that?
Well, I mean, it kind of makes you think about how decisions are made, not just in AI, but in all sorts of systems.
Right, like how things are organized.
Exactly, and
Right.
who gets to do what.
It's funny you mentioned that because I was just reading an article about
Yeah.
how some companies are actually experimenting with self-organizing teams,
Interesting.
where basically there's no manager.
Wow.
And people just kind of gravitate towards the tasks that
That they're interested in.
they're interested in and that they're good at.
Yeah.
And it's supposed to be like
More efficient.
more efficient and more
Or engaging.
engaging for the employees.
It makes sense.
But before we go too far down that rabbit hole,
Yeah.
I do want to come back to AOE
Sure.
and
Yeah.
talk about some of the limitations.
Right.
Because every groundbreaking idea has its challenges.
Oh, absolutely.
So what are some of the challenges with this AOE approach?
Well, one of the key challenges that the researchers themselves acknowledge is the computational overhead.
Okay, so even though it's more efficient in the long run,
Right.
there's still that initial
There's still some upfront costs.
upfront cost.
Yeah, and it's because you have all these experts processing that preview of the input,
Right.
even if they're not ultimately selected to handle the full thing.
So it's like inviting everyone to the meeting,
Yeah.
even though only a few people are actually going to contribute.
Exactly. So there's that trade-off between efficiency and the overhead.
And they also mentioned that the optimal level of input compression,
Right.
that preview we were talking about.
Yeah, that's sneak peek.
Yeah. It might vary depending on the task and the size of the model.
Exactly. It's not a one-size-fits-all.
Okay.
You need to fine-tune that parameter to really squeeze out the best performance.
So there's still some work to be done
Oh, yeah. There's a lot of research still to be
to
done
optimize this.
to really optimize this.
Its approach.
Especially when you start scaling up to those truly massive language models.
Right. The ones with like billions or even trillions of parameters.
Exactly.
Wow.
It's a really exciting area of research, though.
It is. It feels like we're just scratching the surface
Yeah, we're just at the beginning.
of what's possible.
It's like exploring a whole new continent.
That's a great analogy.
Yeah, there's so much to discover.
All right. Well, speaking of discovering new things,
Yeah.
let's get back to that mind-blowing idea of applying self-selection outside of machine learning.
Okay.
We were talking about scenarios where people,
Right.
algorithms, even entire organizations could dynamically choose the tasks that they're best suited for.
It's a really intriguing idea.
It is. So what are some concrete examples of how that might play out in the real world?
Okay, well, let's start with something relatable, like project management.
Okay.
Imagine a team working on a complex software development project.
Okay. Yeah.
Instead of a project manager dictating who does what,
Right.
each team member sees a list of tasks,
Mm-hmm.
and they kind of bid on the ones that they feel most capable of handling.
So they're self-selecting based on their skills and their experience.
Exactly.
I like that.
Yeah, and imagine if those bids were weighted not just by individual preference,
Okay.
but also by some objective measure of skill or past performance data.
So it's like an AI-powered system that helps match people
Exactly.
to the tasks they're most likely to excel at.
Yeah, it's like a matchmaking service.
For work.
For work, exactly.
Instead of swiping left or right on dating profiles,
Right.
we're swiping on tasks and projects.
I love that. Swiping on projects.
This project looks interesting, swipe right.
Exactly.
But it goes beyond just individual tasks, right?
It does, yeah.
Like imagine entire departments or companies dynamically allocating resources.
It's based on real-time needs and capabilities.
It's like a company that can just
shape itself.
reconfigure itself
on the fly
to respond to whatever's happening in the market.
It's like that old saying, adapt or die.
But like actually doing it.
But actually doing it, yeah.
That's amazing.
It is pretty amazing, and it gets even more fascinating.
Okay.
When you start thinking about the role of algorithms in all of this.
Ooh, algorithms.
Algorithms, yeah.
All right. What do you have in mind?
So imagine algorithms not just automating tasks, but actually facilitating this self-organization.
Oh.
They could analyze massive amounts of data, identify patterns, and recommend how individuals, teams, even entire systems could reconfigure themselves.
So the algorithms are like the architects of this.
They're like the conductors.
Self-organizing system.
Of the orchestra, exactly.
That's really cool.
It is. It's a powerful idea, but of course,
we
have to consider the ethical implications.
Right.
You know, we don't want to create a world where algorithms are our overlords.
Yeah, dictating every aspect of our lives.
Exactly.
Algorithm says you have to work on this project.
You're going to work on this now.
No, I don't want to.
Yeah, exactly. Which is why it's crucial to have these conversations now.
Yeah.
While these technologies are still in their early stages.
So we can kind of steer them.
Steer them in the right direction.
In the right direction.
Yeah, and make sure that we're designing them with
human values at the forefront.
Exactly. Human values and well-being.
Yeah. It's not just about
the tech.
Technology. It's about the people.
It's about the people, yeah.
And how these technologies impact our lives.
That's a really important point, and it makes me think about, you know, if we're talking about systems where individuals or components choose their battles.
Right.
How do we make sure that those choices
align with the greater good?
Yeah, align with the greater good.
That's the key question.
How do we avoid like a tragedy of the commons situation?
Right, where everyone's acting in their own self-interest.
And the whole system collapses.
And the whole thing falls apart, yeah.
Yeah, that's a good point.
So one approach could be to design systems with clear objectives.
Okay.
And reward mechanisms that incentivize collaboration.
Okay.
And alignment.
So it's like a game.
It's like a game.
Where everyone has their unique abilities.
But they need to work together to achieve a common goal.
Exactly. And the reward mechanisms have to be designed carefully.
Right.
So that they're fair.
And equitable.
Yeah.
So we don't create unintended consequences.
Exactly, like we were talking about before.
So it's not just about throwing technology at a problem.
Right.
And hoping for the best.
It's about being thoughtful.
It's about being thoughtful, yeah.
About how we design and implement these systems.
And considering both the technical and the human aspects.
Absolutely.
And that's where I think collaboration between different disciplines becomes so important.
I completely agree.
We need computer scientists, ethicists, social scientists, policymakers.
All working together.
To
figure this out.
To
shape the future of these technologies responsibly.
It sounds like we need a dream team of experts to tackle this challenge.
We do. We need all the best minds on this.
And speaking of experts...
Yes.
Are you ready for another round of novel notions?
Always up for some brainstorming.
All right. So for this novel notions segment, I've been thinking about this whole idea of experts knowing what they know. It's got me thinking about like the nature of knowledge itself.
Ooh, getting philosophical.
Yeah, a little bit, right.
I like it.
What if we could design systems where knowledge isn't just passively stored, but it actively seeks out the problems that it's best suited to solve?
Whoa, that's a really interesting idea.
Right.
So you're suggesting that knowledge could have a kind of agency.
Almost like
it's like a living organism.
Yeah, finding its niche.
In
the ecosystem of information.
I like that.
Instead of just sitting there in a database or a library.
Right.
It's like out there.
It's out there.
Looking for the right connections.
Looking for the right people to connect with.
The right problems to solve.
The right problems, yeah.
It's like instead of us going to the library to find books.
Yeah.
The books come to us.
That's a great image.
Right. But how do we make that happen?
Yeah, how would that even work?
What would be the mechanism for this, like, knowledge seeking.
Right.
And that's where I think things get really, really interesting.
I'm intrigued.
Because we could potentially leverage the power of natural language processing, semantic understanding.
Okay.
Imagine algorithms that can analyze text, data, even conversations.
Okay.
And pinpoint the underlying knowledge that's contained within them.
So you're envisioning algorithms that can kind of extract meaning and create a knowledge map that connects different pieces of information.
Based on their relationships.
Based on their relationships and relevance.
Yes.
Okay.
And then we take it a step further.
Okay.
We imbue these knowledge agents with a kind of curiosity drive.
A curiosity drive.
They could actively seek out new connections.
Okay.
New problems.
New areas where their knowledge could be applied.
New areas where their knowledge could be applied.
It's like
almost like a scientific researcher.
Yeah, like a researcher constantly looking for new questions to ask.
New hypotheses to test.
New hypotheses to test.
New frontiers to explore.
Yeah, I like that.
And this could lead to some mind-blowing breakthrough.
Okay, like what?
Imagine these knowledge agents uncovering unexpected connections between seemingly unrelated fields.
Okay.
Solving problems that have stumped humans for centuries.
Wow.
Even coming up with entirely new scientific theories or technological innovations.
That's a really compelling vision.
Right.
But of course, we can't ignore the potential challenges.
Yeah, what are some of the challenges?
Well, how do we prevent these knowledge agents from becoming biased?
Right.
Or misaligned with human values?
Yeah, how do we make sure they're used for good?
How do we ensure that they're not used for malicious purposes?
Those are crucial questions.
They are.
And that's why I think it's so important to involve ethicists and social scientists in the design and development of these systems.
From the very beginning.
From the very beginning, yeah.
We need to think carefully about the potential consequences and develop safeguards to ensure that these powerful tools are used responsibly.
Responsibly, because it's a powerful reminder that even the most groundbreaking technological advancements need to be grounded in human values.
Absolutely.
And a deep understanding of the complexities of our world.
Well said.
It seems every time we delve into these cutting-edge papers, we end up not just exploring new technologies, but also grappling with these fundamental questions about, like, nature of knowledge.
The nature of intelligence.
Intelligence.
What it means to be human.
Yeah, what it means to be human.
They're pretty profound stuff.
It is. It's what makes this journey of exploration so exciting.
It really is.
Well, listeners, we've reached the end of our deep dive into Autonomy of Experts models.
I hope you enjoyed it.
We hope this episode has sparked your curiosity and given you plenty to ponder.
As always, we'd love to hear your thoughts and reactions.
Don't forget to check out the link to the paper in the show notes.
Yes.
And until next time, keep exploring. Keep questioning.
Keep pushing the boundaries.
And keep pushing the boundaries of what's possible.
Exactly.